I hope everybody can see me and hear me. I've got my phone with me, so those of you who have my cell number, you guys can get in touch with me. So let me know. Do I sound 5 by 5, hopefully? 5 by 9? Oh, wow. Hi, Stefan. The first person I looked at the chat, it's the first person I see is Stefan Burns. Everybody, Stefan Burns is, he's become a really very popular space forecaster, space weather forecaster. So I appreciate you coming in here, Stefan. We're going to talk about some very interesting stuff today. And I know there's going to be a whole bunch of people who want to, you know, get the information and go to bed. There's a lot of you in the UK. I'm sorry it took me so long. But this has been a very complicated set of events. So I want to make sure that, that I've got some really good stuff for you that is some data products that are kind of hard to find and hard to develop. So it's, yeah. You see I'm wearing a red shirt. So yes, there's a good reason for that. I see Jerry Ryan and Mike Richardson are both in the chat. Thank you so much, both of you. They are the moderators of the chat, and they will make sure you guys keep in line, so to speak. Please ask questions that are relevant to the forecast. If you have questions that are off topic, no problem. Let's just wait to the end of the forecast, right? Because there's so many people here just want this data and want to be able to get on their merry way. So good it looks. Thank you, Gareth. I see you. I love you, Dr. Skip. Thank you so much. Yes, we will be talking about amateur radio here as well as precision farming. So, because this could be one that's actually going to affect them as well. So yes, red shirt, sounds like I'm okay. So let's jump into this, shall we? Okay, so here's my, whoops. And I see all of you in the chat, by the way. I see you here. I'm going to take the chat off now, though, and we will get back to questions later. All right, let me go to this one. There we go. Hopefully you guys have a clean screen now. And let's do our thing, right? So this is really for June 1st, but, you know, for tomorrow. Okay, so here's our sun. I'm going to start it back on the 28th, and the reason for that was because that was when region 4100, which is the bad boy in all of this, was just kind of getting started. So region 4100 started growing quite rapidly, and we'll talk a little bit more about that in the deep dive. But look at where it is aligned relative to this coronal hole. This is the coronal hole, strangely enough, even as finger-like as it was. This one gave us a G2 level storm, almost G3 if I recall, because it's just got the right polarity. Now we have another coronal hole that's down here. This one doesn't do all that much because it's not the right polarity right now. So this one has been already buffeting the Earth and giving us some decent fast solar wind for quite some time. Bumped us up to G2 plus levels, and so the Earth is really preconditioned. In other words, it's cranky and it wants to storm. So it's not going to take much to send us back up to storm levels. So don't be surprised that when this set of storms hit, we're going to get bumped up really, really fast, irrespective of whether the magnetic field of this storm, because remember, magnetic field directions matter, whether the magnetic field of this storm is going to be the right polarity or not, okay? We will get hit hard immediately just because the Earth is just so cranky and ready to storm as it is. We'll see how it then unfolds after that, but don't make predictions or don't concern yourself too much with how strongly the Earth responds. It's primed to respond, okay? So that doesn't necessarily mean the storm is super strong. Anyway, so as we get to about the 29th, this thing really starts beginning to fire off bigger and bigger flares. But what I want you to recognize is that the whole part of this sun in here over the next 2 days or day and a half or so literally comes off. And we will, if you've anyone ever seen that movie with Nick Cage and John Travolta, Face Off. I want to take his face off. That's what happened to the sun here, and I'll show it to you in a very dramatic way, so you see all of the junk that's really coming at us. Okay, so starting about on the 30th, early on the 30th, we get a kind of a big flare here. There we go. This is an what was it? An M3.4, M3.5 class flare. I'll show it in a sec. But if you notice, it also evacuated a little bit in here. Yeah, there's something going on. There's a filament that goes all the way across here. So as I pull this out, and you can see the big radio blackout. If you were on the eastern part of the world, you probably felt it if you were on amateur radio operators. It wasn't super long flare. It was pretty impulsive, but nonetheless, it gave us a decent radio burst with it. So that is the first. That also sent a big solar storm. Okay, so you've got part of the solar storm launching. There was a little bit that was going on that was synergistically connected over here. But then you'll see a larger part. See this part here? Right. This is what most people think is, oh, this is just going to go to the west of us. It's not even going to give us a glancing blow. Careful though, guys, that's only this part here. If you notice, and I'll show this later, there's this part here that has yet to go. And you'll watch it unfold very slowly. Look, do you see this? See these weird lines in here? And look at it go all the way under here. This is a camouflaged partial halo, which means this part of the storm, it wasn't done. It launched later, and it launched slowly, and we'll see that. But that means this whole section of the sun has launched toward Earth, okay? And this was back on the 30th. Okay, so do you see that? Do you see that little barely there halo, right? I mean, if I had more time, I would have colored it in. So we had this kind of thing that's going off to one side. Granted, that's part of it, right? But we had this camouflaged partial halo in there. Luckily, NASA was able to pick that up, and I was like applauding, going, good, good, you caught it, because this one was really hard to see. And it's also almost a stealthy eruption. So watch, this is the burning of this section. I'll back it up just a smidge so you can watch just watch in here. You'll see like 2 fingers of burning stuff, of light scarring, all in through here, watch. Do you see the light scarring here? Do you see the light scarring here? Look at all this burning all the way out. Okay, so this thing we were still trying to like understand what was going on, right? Still trying to analyze that. Is it going to hit Earth? Is it not? I almost put a forecast out on it. And then lo and behold, boom, we get this massive near X-class flare, right? This was the big one right at the turn of the day. This is an M8.7 class flare. And we'll be playing this a few times, so don't worry if you missed the details right there. We did get a nice, a very nice radio blackout here on the Western Hemisphere. I'll show the geochron global map so that you can see how bad it was. It was pretty intense for a little bit, and it burned for quite some time, and there's a reason why, okay? This is why I'm going to call it, if you noticed on the title of of this live feed, I called it the zipper. This is why. Check this out. Wha-bam! Look at this thing. It just like unzips the sun. Let me go back a little bit. So what seemed to be something that was reasonably co-located all just in this small area ended up being another big filament launch. See how it is like zipping it down? So that's why this coronal hole plays such a huge role, is that you've got a filament channel right next to it. Now, do not be confused. This black hole is not the same as this one. So don't try to line it up with your eyes and go, wait, what am I looking at? No, no, no. This coronal hole is actually a coronal hole where fast wind comes from. What you're looking at in that gray one is where this filament, do you see this filament right here? This filament that comes all the way down all in here, a little bit down in here, right? Goes all the way up and around in here and tucks itself into the corner on the top northern part of this active region. All of that gets blown out, and as that launches, it leaves a scar. And the scar is what looks like this, okay? So that's why this looks so different than the coronal hole, but that's why it's also very massive. Now, didn't we just have an event that came around this way? And now we're having something like this? You see why I was like, this is a lot of junk coming all of a sudden. So as we watch this thing blow out again, see, you can even see where it blows out here. Right? You can watch, look at this, look at the tear. I'm going to back that up. You can watch this like line of lava, it looks like, just tear right down and through here. So all of these areas are very much involved once again, okay? And notice there's a little filament here. This one goes next, so that's yet another one. We'll talk about it in a minute. But in this case, so this is where this massive full halo comes from, okay? And this was a kind of a pain because the data took so long to backfill. So a lot of the early NOAA or NASA predictions kind of were a bit all over the place. Good kudos to them for working with like 2 frames of data. I don't know how they managed to do it, but they do it. So this is the full halo as you can see now, and there's just junk pretty much everywhere. And it's going to be a very interesting ride because this is a reasonably fast coronal mass ejection or solar storm. Now, I'm going back, before we continue to like talk about where this is going in the models, what I want to try to summarize for you using the difference images here, and that's what they are, if you're wondering what this is. I can talk more about them during the deep dive, but I just want to get through them quickly. Using difference images, you can get an idea of how extensive a solar storm eruption is, right, and what they are. And if you use an extended period of time and do something that we call base difference imaging, you can really see the change in something over a long baseline that you wouldn't be able to see very well in raw images. So that's what I'm going to do, is I'm running this through that very first eruption. Okay, and you can see that very first eruption. Remember I talked about how things were kind of, the filament was right in here, this area all in here. Notice it's all lighting up all white. Okay, that is part of a scar that's coming off. Look at this. Now, as this thing begins to do the second eruption, which you'll see here very shortly, whoosh, do you see that? That's the second eruption. Now look at where all the burning is, right? That's the second part. But do you notice? We have literally traced an entire ring around the sun, like we're going to take the face off. That's why I say it's literally like it's taking the face off of the sun. So all of this junk in what is pretty close to the entirety of the Earth strike zone has been lifted. Now, before you freak out, okay, don't worry. Number one, these are filaments. Now they're dense, okay, they're both here. So they are dense structures, but they're not always the fastest structures. So unlike the Gannon storm, right, that was really pushed by a very, very strong solar flare, much stronger than this one, and was moving much, much more quickly. The issue that we have with this is that, my goodness, I mean, you couldn't have gotten this better. The sun could not have aimed better. And just the sheer volume of material that we're going to be getting over the course of the next few days, that's another reason why. If you wonder why NASA and NOAA, well, NOAA in particular, has raised it to a G4 level for both the first and the second. The fast solar wind that we had ahead of the storm too also blows everything out and kind of, you know, cleans up the solar wind, kind of pushes the traffic jams out of the way, which I would have said would have caused the storm to arrive right about now if, I mean, really, really fast, if it weren't for the fact that we have this first eruption that then kind of is now back in the mix and is much, much slower. So this eruption here was actually not expected to arrive till the second. And then this one, if it was modeled on its own, was expected to arrive on the first. So obviously what we're going to have is the slower one ahead is going to be swept up by the faster one behind it. And the question is, how fast can this faster one push? Okay, so that's the tricky part, and that's the hardest part to understand and hardest part to forecast. So yeah, so I'll dive a little bit more into that. But anyway, this is why I wanted you to see the extent of all of this. Now, believe it or not, we're not completely finished. We had, let's see, there's one eruption right there, so there's more junk coming out of the coronagraph, and that's kind of going to the southwest of Earth. But we have yet another boom right there. This, I'm still waiting to see if we're going to get much out of the coronagraphs. It looks like we might, but this might be yet another slow-moving or slower-moving storm that will come after the big one. So that may come around June 4th or so, and I have that reflected in an optimistic way. I have that reflected in the 5-day forecasts, okay? So be aware, this is still an ongoing thing. This region is far from done, and we can talk about more about that in the deep dive. Expect as it continues to rotate across the western part of the disk, it will be active for, I would say, easily 3 to 5 days. We also have regions I'm not even talking about on the sun's far side that are going to be rotating into Earth view. They are new. There are ones that are solar orbiter has witnessed them growing here over the last maybe 48 hours. So we will have some new regions rotating into Earth view, and they may be very flare loud. Okay, so be aware of that. And then we can talk more about some other coronal holes, but I think those coronal holes are the opposite polarity. We'll see. Right now, let's just get through the big storm, okay? But it's going to be a very stormy week, so expect to see a lot of red when you look at those 5-day outlooks. Okay, so now I think what we'll do is that we'll go ahead and switch to, let's see if I can do this. Will you? There, it's trying. Okay, play. Oh, this is cute. There we go. Okay, so let's switch to our solar storm prediction model. So this is, I'm going to show you both NASA and NOAA's. This is NOAA's model. The top panel is density, the bottom panel is velocity, and you're looking down at the sun from the North Pole with Earth being off to the right. And as I set this in motion, they are going to show you the wispy thing that was coming off to the southwest. I don't think they caught the part that hooked back around and gave us that little halo. So already this solar storm, this is just going to be pushed out of the way, while this faster one, as you can see here, has a clear line straight to Earth. That I think is optimistic. I think literally that there's a piece of, there's some junk ahead of this that's going to slow it down. It's not like it's in this fast solar wind of just simply, 700-800 kilometers a second. I don't think it's going to be that easy of a trip for it to get here. That being said, if it is slowed down by junk in front of it, that will compress that junk, right, and make it magnetically stronger, so it could have a bigger hit when it actually hits Earth. It could feel more like a brick wall. At any rate, following their model to its end, what they have it is about 1400 UTC on the 1st is when they're expecting this to get, this particular storm to hit us. Remember, this is just a density plug. This is not magnetic field, so don't freak out. We're not looking at necessarily 50 nanotesla. We're just looking at, a nice strong density plug. But these models, again, do not take into account the magnetic field. The magnetic field is kind of there for a ride. So it's not as realistic as we'd like it to be, but it actually gives us a decent idea as to when, in this case, when we might expect the storm to hit. I would think that this could be one of the early windows, but then again, there's stuff in front of it, right? So how does that come in? Well, we'll see. We'll see. All right, I think that's good for that one. Now let's switch to NASA's prediction model, and I'm using the slightly different color. This time I'm just using the velocity panel. So again, you're looking down at the sun from the North Pole with Earth being off to the right. It's a different color because I'm not using density, I'm using velocity because I want to show you how fast this solar storm was when it launched. This thing was going probably over about 1,200 kilometers a second. These guys captured, NASA M2M folks captured it quite well. But what they have, again, is that as it reaches Earth, notice you still see this gray? Well, that means it's still over here around almost 1,000 kilometers a second. Yikes, I just don't think it's going to be 1,000 kilometers a second. This is the bulk of the structure. I just don't think it's going to be that fast when it hits us. I think there's more junk in the way than we want to believe. I think we have this thing hitting, when it hits Earth, it's still almost, it's about 1,000 kilometers a second, not quite, maybe just slightly under. I stopped at the black for some reason, I have no idea. Hang on. And then I'm going to push it. So they have about 1,200 UTC on the 1st, so that's 2 hours earlier than NOAA's model. Again, I think this is optimistic. But if there's junk in front of it, well, that junk may arrive around this time. But what I don't think is going to arrive at this time is the fast storm. I think that storm is going to arrive after we get a little bit of a junk stuff first. So it's hard to know, if we're actually going to see, because everything's going to be so compressed, it's going to be hard to know if we're going to see actual clear rotations, multiple rotations, because there's several filaments involved, if we're going to be able to cleanly see two structures, or if it's just going to be this big pancake mess like we had with the Gannon storm. Hard to say. But nonetheless, don't think it's going to be as fast, don't think it's going to be as strong. But this will be an extended storm, so I do expect that we'll see storming over the next couple days. I think I went even further on this one a little bit. There you go. So we could see that by the time we get through this, from their estimation, it'll still be, this thing will go by fast. Again, I think that's a bit optimistic. I think we'll still be storming into the 2nd, and possibly into the 3rd. We'll be getting a bit of a lull, and then we might start storming again because we have that other smaller solar storm behind everything right now. And who knows, there may be more coming after that. Probably not as intense as this one, because active regions just, they blow out all that stuff in front of them, and when all that material is gone, there's nothing left. So likely not going to have that much strong storming after, let's say, about the 2nd and 3rd. But the chances of storming are still continuing. Okay, so now switching to our current conditions with our global geochron map. Right now, you're seeing lots of radio blackouts on Earth's Dayside. In fact, getting up to about 20 to 25 megahertz for degradation of signal is not unexpected right now. You could actually see this was the big flare. This was the big M8 8.2 flare. You can see all the radio signals if I do this. Look, they just all disappear. So, in fact, I think all of them do, yeah. So you can see there's just no penetration in this area. So those of you who are experiencing radio blackouts, on HF and VHF, so sorry about that. It's going to be probably continuing over the next probably 3 to 5 days, maybe longer, especially if the regions on the sun's far side end up being a big mess too. So you're just going to have to, deal with that on Earth's day side, try to go to higher frequencies. The nice thing is that as we switch to, the L1 band where we look at GPS and GNSS and the risk for scintillation, our road heat map is really not out of the ordinary. We're getting a few scattered stuff on the day side, a little bit more stuff in the polar regions, just because we've had a little bit of aurora. But really, overall, it's not been significantly worse than what normal is, and that's kind of a godsend right now, considering we're going to be expecting some bad days coming up. Aurora has also not been too bad. Like I said, we've been coming down from that fast solar wind, so we haven't had too much aurora going on. The oval power has been sitting under 50, but that's going to change. And as it changes, it's going to cause significant issues, because right now we are in, as you can see, a radiation storm. So I'm back to DRAP, so you can see at high latitudes we do have what we call a polar cap absorption event. That is causing navigation issues, it's causing communication issues, especially at high latitudes. And then when the storm hits, well, that's going to ramp up the aurora, and that's going to cause problems with navigation and communications as well. So it's going to be a double whammy for everyone here over the next probably 2 to 3 days. So all you pilots, please be aware, if you're using, and GPS users, please be aware that you're going to have reception issues easily over the next 2 to 3, maybe 4 days before things really just kind of finally calm down. And this does mean both for GNSS services and RTK as well. Those networks will also be impacted. How bad is it for Starlink? Yeah. I'm sure they'll feel it, but I don't think it's going to be as bad as the Gannon storm. Now, switching to something that's nicer for all of you Aurora folk, right? We are coming out of a new moon, and we're on our way to a third quarter. Is that right? Coming out of a new moon on our way to a first quarter. Sorry. And I think by the 5th, the moon will be about 72% illuminated. Did I get it? Yes, I did. Okay. So the moon is getting brighter and brighter as we speak. So those of you who are in the fire-impacted areas and in Canada, I know that moon is probably going to create a lot of that nasty haze that you don't want to see. So if you're going to get aurora, catch it early, right, and pay attention to those rise and set times, because the moon will start getting pretty bright by the 3rd or 4th. So hopefully by then we'll get most of our aurora views, but I'll be hoping the fires calm down for you. Okay, let's see, what else do we have? And now, we're going to switch to our 5-day, finally. Okay, so for our solar storm and aurora possibilities over this coming week, there's a lot of red in this. Okay, and right now we're expecting a severe storm starting around June 1st. NOAA just upped this to a G4 watch. Okay. Again, my problem with jumping up to a G4 watch right away, I'm of two minds. My first mind, so to speak, is that the Earth is already preconditioned and ready to storm, so it could jump up to a G3, G4 right away if it gets hit really hard. Okay, so that's one thing. But on the other hand, the problem that I have with that is that we have that other softer, slower storm that will slow down that the fast storm behind it, and how much it slows it down is really going to dictate how hard they end up slamming into Earth right away. So I'm still going to keep this as a G3, but I'm putting it at about an 85% chance of possibly a G4. Now, by the 2nd, I'm expecting definitely a G4. In fact, about a 90% chance of a G4. So this is aurora at high latitudes. I did my best to try to show you what the high latitude aurora looks like. Where you see it on the globe as it's moving. Okay, good. And then by about the 3rd, I'm expecting things to calm down just a little bit. But if we do have that new solar storm that looks like it's launching, it's just kind of in the process of launching, if it does end up giving anything like a partial halo in the coronagraph data as it comes down, then by the 4th, we might get storming again. So aurora photographers, if you're at high latitudes, you could probably get aurora pretty much all this week. And of course, I'm talking mostly about the southern hemisphere, because you folks at high latitudes in the northern hemisphere are hating life because of the sun. But if you can drive south a little bit and get to some twilight areas, that aurora might be very bright, and especially on the 1st and 2nd. So there's a good chance that you'll be able to catch aurora even if the sky isn't completely dark. So it might be worth a shot for you. Okay, now let me switch to mid-latitude. So now mid-latitude, you can see the aurora here. It's a little bit higher. I'm trying to get the bands, where they roll oval might be for you. So this is coming down into the United States. It's coming down into the lower part of Europe. It's coming as high as, Australia, getting into Perth and areas that are that far north. You can definitely see it. again, not expecting this to be a Gannon level storm, right? But we've got a severe storm watch for the first, which will likely go into a G4 level storm. Are we expecting to see a G5? No. Do I think maybe HP 30, for those of you who know those indices, HP 30 might hit a G5? Yeah, possibly. Might pop up there for a short period. I don't think it's going to be sustained. So that's why I'm not as concerned about it when it comes to the power grids, let's say. Weak power grids, the ones that are already strained or have a lot of renewables attached to them, that are already kind of, having issues. I'm not going to mention any names, but there are some places in the world right now that have a few power grids like that. Those guys might have some glitches, might need to have their operators be sure to man the stations and not let parts of the power grid shut down as we ride through the GICs, especially around June 2nd, because that could be a bit of an issue. It's also where we're expecting to see the worst for the GPS outages or disruptions for you precision farmers. And then by the June 3rd, we should get a little bit of a respite, but again, we might start storming and having that storm linger as we go into the 4th. Not expecting that storm to be super big, but again, Earth is going to be already so preconditioned to storm by that time that it may not take all that much. So even at mid-latitudes, we could be storming for quite some time through this week. So there's a lot of red on that map. Okay, now let me switch to our solar flare and Dayside radio blackout outlook over the coming week. I do not know. I have not had a chance to take a look at the solar flux. Last time I saw it registered was around 157. I believe it's probably jumped up to the 170s. It wouldn't surprise me if it's even higher than that. So I apologize if these numbers are off by maybe 10 solar flux units or something. But I do believe that region 4000 or 4100 has managed to bump that noise up and bump that solar flux up to high levels. I do believe that is going to continue throughout this week. It might calm down just a little bit, but not too much. Today, we're definitely under a severe noise watch, or at least we will be through the June 1st, but expecting about a 75% chance of M-class flares with about a 25% chance of X-class flares. This is in an R3 level radio blackout, and that's likely going to continue throughout this week because these regions are still going to be in Earth view. But probably bumping back down to moderate noise level as we move into the 2nd, hoping things will quiet down and that 4100 will kind of, get tired. So the amateur radio operators and emergency responders just kind of deal with the fact that we've got this, these issues over the next few days. Understand that if you might need to bump up to higher frequencies if you're on the day side, or just wait to talk perhaps on the night side if you're doing a lot of rag chewing. Okay, and yeah, and hopefully next week will be better. Now let me jump to our radiation storm and polar aviation outlook over the coming week. Right now we're sitting at the D2 minor range. This is at flight level 360 for you aviators. It's also an S1 stormy range for the rest of us. Expecting this D2 minor range to stay pretty high. I mean, I don't think we're going to bump to an S2 level, but we will peak in terms of the radiation storm and that polar cap absorption area of that. We're going to peak once that big storm, the shock wave from that big storm hits Earth. Okay, so it's going to pop up that flux quite a bit, and then it'll start ramping down more quickly. Hopefully it will die down very quickly. I'm being very conservative when I say that we still may be in the D2 minor range by the 3rd. But our radiation, or chances for an S1 to S2 radiation storm at that point will be much, much lower, simply because our fluxes will be down. But hopefully by the 4th, we'll be back down to a D1 normal range. So you aviators, and this does include you frequent flyers and high-risk passengers and air crew, please take this into consideration in your flight plans. And again, if you're also GPS and GNSS and you guys are at high latitudes, know that this is also going to impact your GPS and GNSS reception over the next few days before things calm down. Okay, and that's it. So I'll make a quick summary real fast, and that's basically that we're going to be expecting this kind of complex solar storm hitting here. Could be within the next 12 hours or so. Likely going to be a bit fashionably late. That will all depend, but we could be getting a kind of a two-parter, because we do think that first solar storm that's a bit slower than the second one, that will hit first, and then it'll be pushed and compressed by that second storm. Earth is going to it's going to respond pretty hard, pretty fast, so we could jump up to G4 levels almost right away. So Aurora photographers, if you're at high latitudes, I know in the northern hemisphere there's too much sun. Consider going south a little bit because the aurora will still be very bright. And so even if the skies are slightly lit up, you still might get a chance of seeing it. Aurora photographers, if you're at mid-latitudes, of course, just look up. Step outside and look up because we could be seeing aurora in quite a few number of places. Now, amateur radio operators, well, yikes. This is just kind of grin and bear it and hang in there this week. It's not your rig, I promise. On the day side, jump to higher frequencies when you get those radio blackouts. On the night side, when the solar storm hits, go to lower frequencies. That will help you. It'll help mitigate things, but probably by the second, the bands may be completely dead. And I apologize for that. I wish AM radio could handle it a little bit better than it does with these big storms. But if you happen to know, if you're an amateur radio operator and you know somebody who's a precision farmer, please let them know what's going on if they happen to be your neighbor, because the precision farming industry is not nearly as well versed in this as we all are. And no, you don't want them having to check their tractors and their connections and bother the John Deere folks and all that kind of stuff either. Because I think they're still in the planting season for peanuts, believe it or not. I think I'll even talk about that in the deep dive. We're definitely still in the planting season and even the harvest season for a couple different crops here, at least in the CONUS in the United States. So I feel for these guys. I hope their farming equipment works okay, and they don't have issues with timing and as well as trying to get their guest rows straight. So keep that in mind. And then, again, you frequent flyers and you pilots, you UAV pilots, be sure to calibrate the magnetometers often in your UAV. You will have likely some issues with GPS reception, especially at high latitudes with this radiation storm. But outside of that, check those ICAO advisories often, okay? And that's it, guys. Hopefully that isn't too long for a nice little chat. And I'll take questions from you guys. And we can go back over some of this, or I can go into stuff that's in deeper. Let me put the chat up on the screen here real fast. How did I do for time? 32 minutes. Hey, that's pretty good. I always try to make the briefing about 30 minutes or so, and I think I did okay. Okay. Oh, cool. Hi, Andy. I'm glad to know that you're here. Let's see. You need to prepare for blackouts. Yeah. So if you live somewhere bright, probably no problem. I'm not sure if you're talking about getting aurora. That's going to be hard. Oh, planting corn soon in in Pacific Northwest. Oh, I missed that. Planting corn will be soon to pass on the information to my neighbors. Thank you so much. I missed your name. Who was saying that? But thank you. Please do, because this is an issue. I mean, I know it's not during. It's not during the spring or the fall, right, when we typically get the strongest storms. But, the sun launches stuff when it wants to. And luckily we're closer to the solstice, and that actually kind of subdues some of the activity, or at least the connection of the activity. What will EPAM tell us? Well, EPAM, it's a little bit tough to use EPAM right now because we have an ongoing radiation storm. So be careful when you read those data products, because those are already elevated due to the radiation storm. So superthermals also come with radiation storms. But yes, it will tell us when the shock is coming. So what he's talking about is there's an instrument on ACE, it's called EPAM, and it basically looks at what we call the superthermals, which are not quite like, they're not relativistic, they're not the super high energy particles, but they're also not the normal solar wind particles either. They're kind of in the middle. They're a little bit faster than that. We call it the fast tail of the distribution of the solar wind, typical solar wind particles. And what we're seeing is acceleration of those particles from the shock. That's the coming shock. So it's kind of like the shock is announcing its arrival. And so we start seeing them before the shock actually gets here. The problem that you have is that the superthermals are also being lit up because of the radiation storm that's ongoing. So trying to distinguish which population you're looking at is a bit tough. So just be careful with that, because it could fool you. But yes, it is a good thing to watch for sure. You're welcome. Oh, thank you, Mark. I saw Storm Deck. I thank you for that. I appreciate that, saying that this was useful. I'm glad. Will we see the aurora in Wales? Yes, you could, very well, very easily, if it hits the right time, absolutely. And of course, if the magnetic field orientation is the right direction. So be aware of that. It's always nice to pay attention to the online communities, or if you're with me on Patreon, I let everybody know if there's, especially with big storms like this, what's going on. I try to answer people's questions as best as possible, but everybody online will definitely let you know. We've got a huge contingent of space weather expertise online now, and all of us want to help you see the aurora and let you know when the aurora is available or is visible in your area. So yeah, check in with Twitter or Twix or whatever you call it, or even Blue Sky. So do I think the second filament won't join the M-class CME? No, they're gonna come together, but no, they don't join. It's not like they'll join because they were launched at 2 separate times, and because of the way the magnetic fields work, it's kind of like having 2 separate magnets. And if you've ever put 2 separate magnets together, you know that they only go together a certain way. And so likely in the solar wind, they're just going to bump off each other, and they'll compress because the first one is just moving so quickly it can't slow down. It's using the second one to slow it down. But so they'll compress a lot, but there won't be a lot of like recombining and stuff. The problem that you have with that, especially with eruptions like this, right? When I go back to, I'll go back to the funky little, let's see if I can make this bigger. Hold on. So I can, there we go. Let's go back to this right here, and I'll just move it forward. Okay. So when we take a look at this, the problem is that this took, what, 2 days? I started showing this like on the 28th, 29th. So to make this whole thing happen took 48 hours, essentially. And so what you're doing, what the sun is doing, is that little bits and pieces, if we call this the sun's face, little bits and pieces are being pulled off, at a time, and it took 48 hours. So we've got basically a lot of tenuous stuff in a 2-day stretch that's a single kind of cloud of junk. And so what makes that challenging to deal with is that if you think about it in terms of a train, I often talk about solar storms as being like a solar storm train. I think I even have that in the title here. So think of a train that's got lots of cars, right? And I oftentimes think of a car as being a solar storm part, right? And they're all kind of hitched together, so it's bam, bam, bam. And you try to stop a train that's got lots of cars in it, boy, it really, there's a lot of inertia there. Well, you can think of it that way as a bunch of cars, but in this case, the cars are only filled with feathers, or they're filled only a couple things in each container. There's not that much stuff in each container. And because of that, what ends up happening is it becomes very, very challenging to know what the inertia of that train is and how hard it's going to hit Earth, and how much it can drive, like the faster part of it can drive the slower part in front if its payload is only feathers, right? So that's where the challenging part of interplanetary science and space weather comes in, is the trip from the sun to the Earth. There's just so much there that we don't have good observations about. We can speculate, but it's really, really difficult when we don't have observations. So hopefully that answers that question. Okay. How bad will the wildfire smoke be? Dad, I don't know. I'm not in that area, and I haven't had time to take a look to see how bad it is. So that might be a question for those in the chat who actually are in those areas. I just know that there's a lot of fire right now, and sadly that's gonna damper the show a little bit for you guys up north. Okay, so I'm seeing Data Adept is talking about opening up a coronal hole. Yeah, I mean, we don't know with all of this, because a lot of this gets lifted off, you don't know how much more. It's always going to widen the coronal hole. Because see, if you can actually see, believe it or not, this is the coronal hole. See this really smooth gray? It almost looks like a lake in here. That's the coronal hole. So you can see the filament tore right next to the coronal hole. That's almost always happens. And when we get closer to solar minimum, this becomes a real problem, because this is where stealth CMEs are born. They lift off so gently you can't even see them. They're very, very frustrating for us because they are always embedded with fast solar wind. So this mechanism becomes a bigger and bigger mechanism and driver of solar storm launches as we get closer to solar minimum. At any rate, this will always end up opening the coronal holes. It's very rare that it doesn't. So the coronal holes do get a little bit larger. They change shape. The edges and the boundaries of the coronal holes change shape because of that. So it's gonna suck. Oh no, Shelby Diamond Star, Mary Beth. Oh no, the fire. It's that bad. Oh, I'm so sorry. Okay, I see a lot of questions going by too quickly. So if I miss your question, please, ask it again. J. Adams, how does the speed compare to the Carrington event? Not even close. The fastest one we had was 14 hours. And that was the 1972 event. And believe it or not, that's not even the one that everybody remembers. 1859 event, believe it or not, the most famous Carrington, right, the namesake of those events, is not the fastest Carrington class event on record, not by a long shot. The only reason why the Carrington class event in 1859 scores so highly in terms of Carrington class events and sets kind of a gold standard is because it was a bad actor in so many different ways. Whereas most Carrington events are only a bad actor in one aspect. If you want to know more about that, I did a whole series about extreme events and trying to teach people about Carrington class events, and that it's really, really tough to get Carrington class events, even back then. This is going to be potentially a superstorm. Will it be as strong? It could be as strong as October 2024. Do I think it's going to be stronger than that? No, I don't think it. Do I think we're going to get a G5? No, I don't think so. And, we could get a bumper car. And those of you who've studied with me know what I mean by a bumper car, where we get this intense EMP, boom, really fast, okay? Low latitudes feel the shock, their power grids suffer, right? Not too badly, but they feel it. And we get this really beautiful burst of aurora right away, and everybody goes, yay, this is going to be a fantastic storm. And then the field flips north and everything just quiets down. And you get this fuzzy, misty, kind of strange, eerie kind of low-burning solar storm aurora, but that's associated with like a northward field. So we can get those, and that is, the 1921. That's a Carrington class event too. That's the railway storm, and that was a big one as well. But that, again, this isn't anything close to those level. Okay, do I think a G4 is a good category for it? Think of October 2024. So anybody who's concerned that this is going to be a kill shot or a big deal or anything like that, guys, we just went through this in October. Okay? Tell all your friends, we just went through this in October. We'll be fine. Okay? Go outside, enjoy the aurora. I'm not even really concerned about the power grid folks on this trip. I was more concerned during the Gannon event, and we rode through it really well. So I think we'll be fine. What I worry about more is precision farming, now that we know it's a bigger deal for them. And now we know how many people are using GNSS in their agriculture, with their equipment and stuff. Okay, hopefully that answered that. How bad will the radio blackout be, and what will be the maximum usable frequency? That changes, right? Do I think that we're going to get R3 levels? I don't even think we're going to get another X-class flare, to be honest. If I flip here for a sec, let's see if I can do this. Oh, good. Okay, so it goes to my other system. I know I've got the chat on here. Let me take the chat off for a second, because you guys can't see anything. Hold on. Okay. So, as you can see, by the way, those who are ready to leave because you got your BLUF, the bottom line up front, you're all good to go. If you're Patreon folks, please put your questions in Patreon, and I'll get to you either in the chat there or in the comment section. Okay, so thanks for those who have been up, who stayed up in the UK and other places across the pond to watch this stream. I appreciate it, guys, and I'll chat with you soon. Okay. For everybody else who wants to continue staying on with me, so this was the M8.2, I think it was right, if I'm trying to remember the numbers. This is an M8.2, this was the M3.5 or 3.4, right, very impulsive. This was obviously much more long burning flare. And of course, this is when we had that massive eruption. I think if anything, we're gonna start seeing it going down even more. I am looking here, though. I will say this. One way that you can kind of tell, those of you who've paid attention in my mini courses, we talk about X-ray flux. Obviously, it's not the same as F10.7, but it's a nice proxy. I like it because it's got lots of dynamic range, and it can see where things are. One thing to pay attention to is the noise floor. Okay? So the noise floor in this wavelength, what is typically the orange typically orange, not the dark colors, but the lighter colors. This is the long X-ray, what we call the lower energy stuff, okay? So pay attention where the noise floor is there. And after a big flare, see if that noise floor, after things die down, granted there are a few other pops in here, but it's still pretty much kind of on that tail dying down. See where that noise floor lands. If it's higher, well, then we may have more activity going. And sure enough, looks like we've hit bottom, and that bottom looks a little bit higher than where we were before. This is, I think we're sitting at the sea floor. Yeah, right here, this line is the sea floor. So, you know, not super horrible noise, but we're still getting stuff. So maybe that hot longitude is rotated a little bit more towards center disk, because it looks like we're going to continue to see activity from region 4100 for, you know, the next few days. Might even get region 4099, which is the one that we really thought was going to go. We're going to get it to go. But I'm not sure we're going to see X-class flares. If this noise floor begins to rise closer to the M-class floor, sure. This gets about a C5-ish, give or take an ish. Okay, and that's not really a rule of thumb. It's just what I know from these from this particular pattern of flares that I'm seeing. Then we'll see. I'll say that the X-class noise, you know, the X-class chances will be higher. But right now, still thinking about M-class, high M. Okay. And again, even if this region does fire off another CME or two, it doesn't have as much stuff left. Okay, you know what I mean? It doesn't have as much material left on the overlying it. So pretty soon these things, if they continue to fire over and over and over again, pretty soon they just become impulsive flares. And you don't see any more gradual flares like this because there's just no more material to evacuate. And so the flares just, you know, they just are, what I call it, firing blanks, right? Shooting blanks. Okay. Will all of Nevada see the aurora? If the aurora, if the magnetic field of the storm is the right way, then yes. Yeah, that'll be easy. Pete says, what is the most dangerous? MGX? Okay, you're careful because you're conflating two different things. MC, MX are for flares, which is what I'm talking about now. The G storm level, that is a geomagnetic storm level. That's once a big solar storm hits Earth. Flares and solar storms are not the same thing. They're two different phenomena that oftentimes happen together, but they're not the same thing. So don't get those two scales confused, because if you think they're all the same, you'll never, you know, you'll be confused forever, because none of it will make sense. So there are two totally different scales. And if you want to know more, again, I've got lots of video courses on YouTube that you can take a look at. You can go to the C series, which is all about coronal mass ejections, which are the solar storms. And then you can go to the F series for solar flares and radio bursts and understand that. So you can get an idea of why we have them separate and what they actually do and how they affect Earth differently. Okay, yes, RK, you're correct. X most powerful. So hopefully just like May 11th, no, this won't be nothing like May 11th. Nice aurora, but nothing like May 11th, okay? Yeah, May was awesome. Yeah, it depends upon who you're talking to. Some people hated it. Okay, Florian asks, what is your prediction for impact velocity and what impacts would that shock bring? The shock will just bring a higher radiation storm level for a while. It's going to affect the satellites in Earth's system much, much worse than us on the ground. And there are all sorts of issues that I get concerned about. Obviously, the one nice thing is that we're at the solstice and not at the equinoxes. So we have a chance that the big impacts will be a little bit less. But considering we've already been storming, I'm not sure. I haven't looked to see if the radiation belts are really tanked up right now. They may be. Let me take a look and see if they've dumped or if they're building up. Ooh. Yeah, satellite operators aren't liking things right now, especially in geo. So what you're looking at here this is electron flux. So once you get across about this is the threshold of flux. What is it, 1,000? Yeah, it's 1,000 PF. You just call them PFUs, yeah. Flux. They're flux units. It's basically particles per certain geometric factor. Once you get over 1,000, that's kind of the rule of thumb where you start having to deal with internal charging in spacecraft. And as you can see, we fluctuate up and down, but we're building. And that's simply because we just got out of that fast solar wind. So we're already in a situation where satellites could be strained. So the idea that the operators might see some single event effects when the shock passes, that's possible. I'm sure they're on high alert about it right now, simply because the fluxes are already in geo, they're already so high. But us on the ground, the issue is more going to be that magnetic field direction. I think we're going to care much more about that, unless of course you're a UAV pilot and you care about the polar regions. But will we get, if you're at low latitudes and you worry about that EMP, again, the longer it takes for that storm to get here, the slower it's going to be. So I think, so that's what you want. You want it to be fashionably late, because then that'll ease your mind that the EMP that we'll likely get from it will be pretty mild. Okay, and I'm expecting a reasonably mild EMP anyway. This isn't a Carrington event, right? This is a much slower. Carrington events are 2,000 kilometers a second. This at its best is under 1,000, and that's the most optimistic estimate. So again, not something that's going to be life altering, guys. It's just a nuisance, right? But it's something that we need to pay attention to. Okay. Do I think, this is Javi, do I think Aurora could go down to low latitudes? If the magnetic field is the right way, yes. But we have to, we can't a priori tell. The neat thing is that because this structure is like curved, the chances of it having some part of it having some southward magnetic field is pretty good. The problem is, how long is it going to stay like that? Okay, I really don't know, and we really won't know until the structure hits and gives us a better feel for it. And of course, I could really talk about the problem with this structure being so large. Because it's such a large structure, we may have overestimated the speed of it. Really big CMEs, when they leave, because when we look at them in coronagraphs, you have an uncertainty that has to do with the size and speed of a structure. If something is coming at you, it could look exactly the same in terms of how quickly it's growing and how fast it looks like it's coming at you. If it is a small structure moving really quickly, or if it's a very large structure moving more slowly. So there is a bit of an ambiguity here. And so that's one of my concerns about this particular event, is that we have a very large structure that, let me switch this back here. I'll show you again. Let me go back to this one. Okay. Hopefully it'll come back on. Okay, there we go. So when you're evacuating something that's this large, this is large. This is a large source region for this structure, this set of structures to be coming from. And so when you're evacuating that much stuff, it's like having a very large ball that's coming at you, as opposed to having a small golf ball moving really quickly. A very large beach ball could move at you more slowly, and from your perspective, it would look, the edges of the ball would grow at the same rate. So we do have that inherent issue when we look at, coronagraph images of these structures coming at them. There's a flattened 2D view of the plane of the sky. Right? It's kind of like looking at a shadow of something, right? You don't know if you're thinking of a shadow of a ball hitting the ground, and let's say the sun is overhead and you're dropping a ball to the ground, and all you're doing is looking at the shadow of that ball and watching how it grows. You got to gauge both the size of the ball and the speed of the ball. But if you dropped a big ball more slowly, then it would grow more slowly as a shadow, or it could grow at a certain rate. But if you dropped a very tiny ball, but you threw it hard down, it would also grow at that same rate. You see what I'm saying? So it becomes a real trade between how big and how fast. And we can't really gauge that. So I'm thinking that there's a chance that we're erring on the side of too fast, simply because the structure is so big. That's just, but that's me, spitballing. Don't know for sure. Could be completely wrong. I have before. Let's see, man with a box. I am very sensitive to magnetic storms. It affects me physically, and I'm not able to sleep. You're one of the sensitive type, and there are sensitive classes of people. It's not necessarily because things are ionizing, it's just because there are people that are very sensitive to electromagnetic radiation that is biologically active. You know, our bodies are electrochemical. So certain people, especially if they have comorbidities, or if they have blood, you know, heavy metal poisoning in their blood, or plates and screws, or you know, or traumatic injuries, especially to the brainstem. There's all sorts of things, implantable devices. All of these things can make you sensitive to the geomagnetic conditions. And sadly, we're at a stage in the solar cycle where we're getting hit by these fast solar wind streams every 2 weeks. So this is probably going to be the roughest part of the cycle for you, and it'll probably last another 1.5 years. But take heart that things are going to get better soon, because things will begin to die down, right? So yeah, that's the best I can say, and I'm sorry for that, but you're not alone. There's lots of people out there like you. And the medical industry is beginning to wake up to that and start doing really serious research on it, which I'm very grateful for. So, okay, so Monday night, well, I would start paying attention here, you know, within the next 12 hours. Just start paying attention, because it's hard to time exactly what that, you know, when it was, or when it's going to hit. It says, just wondering what month it was solar maximum. Oh, I forget. Jerry, do you remember? Like last October, I think it was last October. Yeah, we're definitely past solar max. So much so that's why we're getting these coronal holes down at mid-latitudes, is because the old polar coronal holes have been displaced, so to speak. They've been pushed down into mid-latitudes, and now they're being eroded slowly. Because solar cycle 26 is already set up root. Its dipole field is already set up, and it's got polar coronal holes that are already crowned king. So cycle 25 is being kind of sent to the shredder, so to speak, and it slowly gets eroded and eaten away, and the polar coronal holes are evidence of that. So yeah, we're well past solar max. Okay, yeah, see, other people are talking about getting headaches and having to wear, yeah, certain stuff. Yeah, definitely around RF equipment. I can see that being a problem. Having crunched the numbers on average, but on average an overestimation of the speed. Yeah, we'll see. We'll see. That a lot of times these guys are pretty good, you know. They try to take into account for these types of things. So, solar storms sure affect my CW parks on the air activations. Yes, W4EMB, thank you for letting me know, Ed. And, you know, what's neat is that sometimes you guys, when you do parks on the air or summits on the air, if you guys do POTA or SOTA, the cool thing is that you oftentimes will share mountaintops with Aurora photographers. And if you ever decide to do Aurora stuff and you're doing summits on the air, for example, and you're with Aurora photographers around, it would be really cool if you get auroral propagation, if you could like try to figure out what kind of aurora it was. Because when you see the Aurora photographers taking pictures of Aurora, you know, Aurora isn't just all the same. Some of it is colored differently. Some of it is red and diffuse, which we call SAR arcs. Some of them, of course, are the diffuse auroral oval bands that are oftentimes green with these tall pillars that are purple and magenta and sometimes even blue. And then we have things like dunes. There's all sorts of different types of aurora. And I think it's going to be part of the future of auroral science and ionospheric science. If we can start determining the difference when radio frequencies are refracted by these different types of aurora, if it sounds different on RF radio, we could actually identify the different types of aurora that are occurring in different parts of the sky. And by doing so, that might give us hints as well into what kinds of aurora are more disruptive for GNSS, for example, or HF or VHF, or you know, any of that. And I think having aurora photographers and amateur radio operators and even precision agriculture folks and drone pilots, all of you guys kind of working together as a super community, I think we're going to elucidate a lot more of that stuff and get a better handle on how to mitigate through these solar storms. But we're going to need everybody's help to do it. But I'm really excited that we're you know, a lot of these communities are beginning to work together. So hopefully that was a long-winded answer to your question. Okay, let's see. Maybe looks like, are you guys running out of questions? Hopefully. You guys getting ready, hopefully? Let's see. Keith says, am I going to see any aurora in south central Pennsylvania? You could, depends upon the light pollution, right? And if you notice, there is a ton of clear skies in what looks to be clear skies. If you look at windy.com, for example, Alan always gets me to look at windy. I don't really like windy, but okay. But I looked at it, and it has like a good portion of at least the United States as clear skies. Now, I don't know about the smoke from the fires, but hey, definitely if you get a chance, put clear skies as your number one thing, clear dark skies as your number one thing if you're going to be chasing aurora. Because I think if this storm hits and is as strong as and has the right magnetic field orientation, you won't have to hunt for aurora. You will see it. So get the best views you can. Oh, and will you see the aurora? Yes, and I don't live in Pennsylvania, but I teach there. I teach distance learning, but yeah, I think you can. If you get in dark skies, you will. Okay, so get out of the lights, and I think the state or the city that you mentioned is already kind of in a dark area. So yes, I think you're a very good chance of seeing aurora. But make sure that you pay attention to the indicators on social media when the storm actually hits, because that's going to be the big thing. Hey, I missed it. I saw a wave. Someone was waving at me. Okay. Will we be strong enough to see in Ohio with the naked eye? Yes, if the magnetic field, like I said, of the storm is the right direction. You always have to get that the right direction. Okay. No, light pollution does not protect you. But you don't need to be protected, Sven. What's going on up in the upper ionosphere is not a problem. It's not going to give you any issues. Let me just check to see if anybody is on Patreon asking me questions. And then outside of that, I think I will let you go. I do have someone who wants to talk with me from, I believe, the Washington Post. So I just realized what time it was, and so I need to call them. Do I have a good timing on this solar storm hitting? Basically what I gave you, right, earlier in the briefing. It should be hitting, any time between midday on the 1st, possibly and through the 2nd, and then things will continue lingering from there. How will it affect us with a weakening magnetic field? So it'll give us less aurora. It'll give us less GICs. Don't worry about the weakening magnetic fields. The only thing okay, and I'll say this so that everybody who thinks that Earth's global polar field shift, if that's what we're going through, if it's not just an excursion, but we're reversing. When you weaken a magnetic field of a planetary body, its response weakens, okay? So the strong aurora shows go away, become less aurora. As a matter of fact, the aurora typically flips to a higher frequency. Look at Mars, if you don't believe me. Mars has aurora in ultraviolet light because it's only got a remnant magnetic field left. It doesn't even have a magnetosphere anymore, okay? Its aurora is very weak. Its GICs are very weak. Why? Because you don't have a strong magnetic field wiggling. Therefore, it's not inducing currents in the ground. So for the things that really, really matter right now, at least when it comes to power grids, okay, and aurora, weakening magnetic field of the Earth makes it weaker. Okay, the storms weaken, right? We already know with our quadrupole magnetic field, we have a strong enough magnetic field that's going to stand off the solar storm well enough to protect our atmosphere. It's not going to strip up our atmosphere. We're not going to have pickup ions any more violently than we already have. It's really not that big of an impact, okay? The only area that I worry about is when it comes to penetrating radiation, okay? And that's just for aviation. So right now, we already talk about having an S1 level radiation storm. How much worse is that? Not much. Okay, but will we see more radiation penetrating in more areas? Yeah, around the South Atlantic anomaly, yes. And as the South Atlantic anomaly continues to stretch and break off into 2 different sections, become essentially two poles, so we have a multipolar Earth, which is likely what's going to happen. Like a textbook, this is what happens. Because our magnetic field isn't going away. It's just the dipolar field component of the magnetic field. The field, the Earth's magnetic field, is made up of lots of different components. So the quadrupolar field and the octopolar field and all these other components, higher order terms, will still be there. Okay? So the field itself is not dying. Don't worry about it. What sucks is that we may have weaker aurora. What will be challenging is that the whole space weather environment in the near-Earth environment is going to be wild because we have a multipolar Earth. What do we have? 4 different sets of radiation belts? Does that work? Do we even have radiation belts? I don't even know. How far does the particles penetrate? I don't know. That's what's going to be a real challenge, is more dealing with the space assets. Who knows? It might even actually make it easier on them, because without the strength of a magnetic field, the strong dipole field component, you can't accelerate the particles. So just like with CERN, Earth's magnetic field is a particle accelerator. You weaken that magnetic field, it can't effectively accelerate as many particles. So perhaps the environment becomes much more benign. It's not as dangerous as people might like to make you think it is. It's actually the opposite. So I guess I kind of giggle, but by the same token, I kind of get frustrated that people are making you feel scared of something that actually is going to be helpful. In many instances, it's going to be helpful, especially when it comes to our technology. So, I hope that it helps answer the question. And if your heart was beating fast and you were panicking about it, thinking I'm ignoring the whole point about magnetic fields, no, I'm not ignoring the point about magnetic fields. Everything will be fine. It's actually going to make things easier in many ways. So, but like everything with space weather, it's always a mixed bag, right? Makes it easier and better when it comes to dealing with solar storms and stuff and GICs. Not so great for particle precipitation, and really where I get concerned is solar minimum. When we have cosmic rays bombarding Earth, now we have a weaker geomagnetic field and we have cosmic rays bombarding Earth. Those fluxes are going to go up. Those are the things I'm concerned about. It's not even about solar storms. So, maybe someday I'll do a mini course on geomagnetic fields and when they change, what really happens, because then I could just point you guys to that instead of having people be so panicked, because I don't want you guys to panic over Earth's magnetic field moving and changing. This is what it always has done, and we're still here. It's really not as bad as you think. Okay, get off my soapbox now. All right, guys. And that just reminds me, Jasmine, you mentioned, you say, how is the southern aurora different from the northern aurora, viewing from the southern coast of New Zealand? To be truthful, they're mostly conjugate. However, and this brings up another good point about the magnetic field changing. In the longitude where there is the South Atlantic anomaly, which is a depression in Earth's magnetic field, the aurora gets weaker. So if you want proof of what Earth's changing magnetic field is going to do, we have the proof, okay? You weaken the Earth's magnetic field, the aurora gets weaker, the geomagnetic induced currents, they get weaker. Okay, we have the proof already, because all we have to do is go to the longitude of the South Atlantic anomaly and we see it. So, and that is, so aurora in that region especially is weaker in the southern hemisphere than it is in the northern hemisphere. Crazy, isn't it? But it's true. So, so how does that affect New Zealand? It won't. You essentially will get the same aurora in the southern hemisphere as the northern hemisphere. There are some differences, but for the most part, you're not going to be able to see the differences, because the people in the northern hemisphere, well, they got the sun right now. So the big difference is that you're going to be able to see it and they won't when you're at high latitudes. How's that? Hopefully that made you cheer up. Oh yeah, bird migrations, absolutely. Thank you for reminding me. Yeah, you can actually watch them live, and they go crazy when there's so many more birds in the air during big storms. So this is going to be another big storm to watch bird migrations and watch the changes. So those of you who might know people who work with pigeons or work with birds or are concerned, especially if there ends up being lots more incidents over the next week of birds hitting windows and doing weird things, yeah, it's the storm. Sadly, this happens quite a bit. Okay. Yeah, I'm gonna have to take off here, guys. I have like just one. I'll take one or two more questions. Let's see. Tamitha, how can you determine if a coronal hole is a positive or negative magnetic field, but not for a CME? Because you can. Well, the easiest way. I mean, I could go to another way too. Well, but the easiest way is to go to the Space Weather Prediction Center. Here. Go to the Space Weather Prediction Center and take a look at their synoptic map. Can you see this down here? Synoptic chart. Click on that, and their coronal holes will be not only numbered, but given a designation. So it'll be positive or negative. And the best way to remember it is that if you want storming, so if you're an aurora photographer, all you remember is SNAP, S-N-A-P, spring, negative, autumn, positive. Because these coronal holes become, the polarity becomes much more geoeffective near the equinoxes. Now, we're not near the equinox now, but we're not quite at solstice. So we're closer to the spring equinox than we are to the fall equinox, so it would be spring negative. And sure enough, we are in a negative polarity region. So you can see it right here. This is why I know that this filament area is going to be a bit more geoeffective. Okay. Now, is this perfect? No. So don't, think that, oh, you've got a recipe for everything. You don't. Okay, because a lot of times there's mixed fields. A lot of times you don't know when the magnetic field is being tweaked or twisted in the interplanetary medium. So there's a lot, but this is kind of a rule of thumb. Okay, so, oh, and yes, I guess the other coronal hole is negative as well. So that'll be a good geoeffective coronal hole as well. That's one way. Another way, of course, is to use J helioviewer and add magnetic field lines. I'll see if I can. I had this set up for, yeah, so you can add magnetic field lines. Let me reset the view. And you can take a look at, oh, it's not going to, it may take too long to load them. I'll just put this back to, I get one right here. So you have magnetic field lines, and you can see in the color of the magnetic field lines how they're coming out of the different parts, whether they're towards or away. And I think I've talked about this before in different classes I've done, and I can talk about that at some other time. But yeah, so J helioviewer is a great tool to use for that kind of thing if you know what you're doing. So hopefully that helps. Okay. All right, guys. Yeah, I hope we don't lose our history every 6,000 years. If it is, it's because humans burn libraries and whatnot. Yes, no cave needed. Got it. Okay, guys, have a great one. I'm going to try to see if I can catch up with that reporter. They haven't left for the day, and see if we can keep people from getting too frightened about the coming storm. Enjoy the aurora, relax, everything is fine, and step out to social media and take a look at what the community is doing, because they're wonderful people, and they will keep you apprised, and that'll be people both on I know on Twix as well as on Blue Sky. So, and Facebook, of course Facebook. That's a great place for lots of different community groups in different locales. Okay, and you'll definitely find aurora photographers out there who are in your neighborhood. So, enjoy, and yeah, just stay vigilant if you are a radio person. Okay, bye guys.